At 6:14 a.m., a frozen world beyond Neptune appeared 3 arc-seconds from where 30 years of orbital physics said it had to be. By sunrise, 4 observatories had confirmed the error. The object was not malfunctioning. Its orbit was being pulled, and before anyone knew what was out there, the solar system had already begun, quietly, invisibly, to come apart. What follows is a thought experiment, not a prediction. One improbable path through real, unforgiving physics. The graduate student who found the anomaly did not gasp. She recalibrated the instrument, rebuilt the orbit, and asked another team to repeat it blind. The second team found the same residual. Then a third object drifted. Then 6, each wrong in a direction that agreed with all the others. One bad orbit can be noise. A family of bad orbits is evidence. And evidence this coherent demands a source. No planet in the catalog could provide enough mass. No software error could pull independent telescopes toward the same invisible point. Archival images revealed years of weak micro-lensing, background stars brightening, shifting, then returning, as unseen gravity crossed in front of them. The first clue was not darkness. It was light, taking a path it should never have needed to take. Trajectory models converged on a single visitor moving in from above the ecliptic, toward the outer planets. Its mass estimate kept rising, hundreds of suns, then thousands, while every search for reflected light returned nothing. The anomaly had a name. A black hole does not announce itself by being black. Space is already black. It announces itself by rearranging everything around it. The best-fitting mass in this scenario is 4,000 suns, an intermediate mass black hole, rare but not a fictional category. LIGO has confirmed an intermediate mass remnant. Astronomers have other candidates. A solitary 4,000 solar mass object near us, however, is entirely hypothetical. For clarity, we choose a non-spinning black hole. Its Schwarzschild radius is about 11,800 kilometers. That is the radius, not the width. Its event horizon diameter is roughly 23,600 kilometers, almost twice Earth's diameter. But the visible darkness would look larger, because strongly bent light creates a shadow beyond the horizon itself. At first, there is no bright accretion disk. Interstellar space offers too little gas to build the glowing furnace familiar from movies. Instead, telescopes see background stars magnified, split, and displaced. The black hole remains invisible. Its gravity signs the image. This is gravitational lensing. Mass curves space-time, and light follows the curved geometry. It is also why the first images must stay restrained. No blue vortex, no fantasy nebula, no ring of fire without fuel, and no cosmic suction. At equal distance, a black hole pulls exactly as any other object of the same mass would. If the Sun were replaced by a one solar mass black hole, Earth's existing orbit would continue. The danger here is the extra mass and the encounter. 4,000 suns entering the planetary system create a moving gravitational center far stronger than the Sun. Yet every outcome still depends on geometry. Some bodies are ejected, some are redirected, some exchange energy and become bound. This film follows one low probability branch. A many-body encounter leaves Earth captured on a plunging orbit around the visitor. Not because gravity chooses Earth, but because, among countless possible trajectories, this is the one our title asks us to follow. Long before Earth is threatened, the loosest architecture yields first. The Oort cloud, a distant reservoir of icy bodies barely held by the Sun. The black hole's tide does not pull them all inward. It sorts them, outward, inward, and sideways, according to position and speed. Some comets escape forever. Others begin journeys toward the planets that may take decades or centuries to complete. That delay matters. Gravity acts throughout the system. Consequences appear first where binding is weakest and timescales are longest. Closer in, Kuiper belt orbits develop correlated residuals. Astronomers refine the mass, direction, and arrival time. Observatories stop competing and begin sharing raw data. Ephemeris teams recalculate the future of every tracked body. For most people, life remains ordinary. The discovery is enormous, but its first human consequence is uncertainty, not impact. News anchors learn the word perturbation. Markets swing. Schools stream telescope images of an object no camera can directly see. Then the giant planets move off their old predictions, not violently, but enough that decades of precision stop agreeing. Neptune's path shifts first in the models. Uranus follows. Moons and rings respond through altered resonances, not cinematic explosions. Spacecraft navigation begins to require new gravitational models. A radio signal arrives on time. The predicted antenna pointing is wrong. That small discrepancy is terrifying because deep space navigation works only when the solar system behaves like the solar system. The visitor's tidal field grows as distance shrinks. The sun, planets, asteroids, and probes all accelerate, but not by exactly the same amount. Those differences, not the shared fall, tear orbital relationships apart. This is the real engine of the catastrophe. On-screen clocks jump years, then months. The approach is compressed for storytelling. The dynamics themselves are not instantaneous. At the end of the approach, the mystery is over. The remaining question is which pieces of the old system leave together. The outer planets do not line up and fall one after another. They enter a chaotic, many-body encounter. A tiny difference in starting position can decide whether a world is captured, expelled, or left circling a displaced sun. Neptune acquires a new, elongated orbit. Uranus is flung outward in our selected simulation. Neither outcome is universal. Saturn's rings remain bound to Saturn at first, while the planet's solar orbit changes beneath them. Jupiter bends the paths of smaller bodies, but even Jupiter is only 1/4000th of the intruder's mass. The Sun itself accelerates toward the black hole. Planets are not simply abandoned. Their common reference frame is being rewritten. Now, cometary traffic rises. Most objects miss every planet. A few strike because chaos turns old safe distances into crossing paths. The film shows probabilities, not a guaranteed meteor apocalypse. Isolated impacts, new dust, and a sky monitored without sleep. Satellite catalogs become obsolete by the hour. Operators spend fuel preserving essential communications, while less critical spacecraft are abandoned. Global navigation degrades as orbital predictions age faster than they can be distributed. Aircraft and ships fall back to inertial and ground-based systems. The failure is not magical. The satellites still transmit. Their positions have become moving answers to a changing gravitational problem. Electrical grids remain intact, hospitals remain open, and people still go to work. Catastrophe arrives unevenly, through systems built on predictability. In this branch, Earth receives a gravitational assist during the Sun-black hole encounter and loses energy relative to the black hole. That sentence sounds gentle. It means Earth is no longer primarily orbiting the Sun. The new path is extremely eccentric, a long fall toward a closest approach deep inside Earth's tidal disruption distance. The Sun recedes from its familiar position. Day length survives for now, but seasons and solar heating no longer follow the old calendar. Climate models become weather reports for a planet whose year has stopped meaning what it meant. There is no engine capable of changing Earth's momentum by the required amount. Rockets can move people. They cannot move a world. Proposed shelters answer hours, not physics. Evacuation to another planet fails because the other planets are moving through the same encounter. Some spacecraft depart Earth, but escape from Earth is not escape from the black hole's new gravitational domain. For the first time, every clock counts toward the same event. Pericenter, the nearest point of Earth's last orbit. And the distance at pericenter is not the horizon. It is far outside it, where a planet can no longer hold itself together. Tidal force is a difference. The near side falls slightly faster than the center, and the far side slightly slower. The closer Earth moves, the larger that difference becomes, rising approximately with the inverse cube of distance. For this 4,000 solar mass black hole, Earth's rough tidal disruption distance is about 9 million kilometers. The exact value depends on rotation, strength, internal structure, and trajectory. But it is roughly 750 horizon radii away. This is the correction the earlier script required. Earth does not reach the event horizon intact. First, ocean tides cease to be coastal rhythms. Water piles into vast bulges aligned toward and away from the black hole. Coastlines disappear under moving walls of water. Ocean basins expose elsewhere. Weather systems stretch around a planet losing hydrostatic balance. The solid Earth flexes too. Faults rupture, magma moves, and global seismic noise becomes continuous. No single earthquake destroys the planet. The growing gravity gradient deforms the entire body until local disasters merge into one planetary process. The Moon's orbit is stripped from the old Earth-Moon partnership. Its exact fate depends on phase. In this branch, it escapes into a separate path. Above the atmosphere, satellites peel away at different moments. Their last telemetry traces gravity more cleanly than any diagram. On the ground, the black hole is still not a giant glowing circle. Its position is marked by warped starlight and a sky that bends. As Earth accelerates, aberration pushes the forward sky inward. Background constellations crowd, duplicate, and arc around the invisible center. There is no universal camera view, so the film anchors every shot to one consistent trajectory and one non-spinning geometry. The final broadcasts do not promise rescue. They preserve measurements, languages, faces, and ordinary sounds for as long as transmitters survive. A child hears rain against a window. Far below, the same water is being drawn across continents. Then, Earth's self-gravity loses the contest. The planet lengthens, fractures, and becomes a stream of mantle, iron, ocean vapor, and atmosphere. There is no explosion in space, only breakup, heating, collision, and a widening trail following almost the same fatal orbit. By the time the debris approaches the black hole, there is no intact Earth left to cross the horizon. But every fragment still carries Earth's matter, momentum, and history. General relativity can follow that fall. The leading stream compresses and collides with trailing material. Rock vaporizes, plasma forms, transient arcs glow, but never a perfect permanent disk. This late glow is the only accretion structure in our continuity. Thin, broken, white gold, and physically tied to Earth's debris. The event horizon is not a surface, it is a causal boundary. From inside it, no future-directed signal can reach the outside universe. For a non-spinning black hole, the horizon lies at the Schwarzschild radius. Nothing special must be painted on the boundary itself. To explain the crossing, imagine one surviving instrument package riding a dense fragment, transmitting pulses outward. A distant receiver sees each pulse arrive later than the one before. The light is increasingly redshifted and increasingly faint. In Schwarzschild coordinates, the crossing is never seen to complete. In practice, the signal rapidly fades below every possible detector. That is not the fragment freezing as a physical shell. It is the last escaping information being stretched into invisibility. For the falling instrument, proper time continues. If tides and heat had not destroyed it, the horizon crossing would occur after a finite interval. There would be no flash, collision, or local alarm at the horizon. Freefall is locally ordinary across a sufficiently small region. Both descriptions are compatible because they compare different clocks and different ways of slicing spacetime. The distant universe does not watch matter vanish at a single frame. The infalling matter does not watch the universe run to infinite age. Relativity permits strange views, not magic. Light is bent, the sky is aberrated, and clocks disagree without violating local causality. Inside, Every future-directed path leads deeper. For this idealized, non-spinning solution, classical general relativity predicts a singularity. A singularity is not a photographed object or a destination we understand. It is where the theory returns infinities and loses predictive authority. Quantum gravity should matter there, but no tested theory tells us exactly what replaces the classical ending. So the camera must stop where knowledge stops. No wormhole is promised. No white hole opens. No other universe is established. What remains is the last outward signal, a redshifted record of a planet that no longer exists as a planet. From far away, Earth's debris becomes a dim, lengthening ember around an invisible boundary. From the falling frame, the external sky is warped forward by motion and gravity, brighter in some directions, compressed into unfamiliar geometry. It does not contain the infinite future of the cosmos. It contains only the light that can still reach that particular fall. The sun is no longer a sunrise. The constellations are no longer shapes. Direction itself is being rewritten. Yet nothing about the final physics makes the life before it meaningless. Scale does not cancel significance. For 4.5 billion years, Earth turned starlight into oceans, weather, cells, memory, music, and questions. Then, in this impossible branch of possibility, those questions crossed a boundary from which no answer could return. A black hole did not hate us. It did not choose us. The universe supplied no villain, only geometry. That may be the deepest terror and the deepest wonder. Nature does not need intention to change everything. We looked into the dark to learn what was there. At the end, the dark revealed the limit of looking. Not a wall, not a fire, a final sky bending closed, and one last heartbeat, redshifted beyond reach,